Good morning, folks. Hello, everyone. Thank you for joining our session back. We are back with a new edition for our virtual data user group. Similar to like what we have done last month itself, at the end of the month, we had one speaker from our AWS team to help us learn about all the data patterns. Similarly, we'll have another speaker today. But before we jump into that, let's understand why you should join the meetup and all. And again, just in case if you have not subscribed our user group yet, please, I'll share the links by once we pass on to a speaker. I'll share the link, so please do subscribe it. Again, for all the people, a lot of people do reach out to me why we should join AWS user groups, what's exactly the advantage of it. So AWS user groups are the chapters for the community, by the community across the globe. So wherever you are, in whichever part of the globe, whether you're in India or somewhere out abroad, you will have some or other local chapters nearby to you, which you can check and join. The advantage of that is you will able to learn, network, and get many opportunities like job referrals, upscaling, certifications, new trends in the technologies. So there is lot to exchange, learn from these people, from the community. So that is why you should join. If you have not enrolled, again, I'm not saying you should join X versus Y, but if you have not enrolled any user group, do it right. I'll give the link so you can look up to the chapter nearby you. And just in case if you're based out of India and you're finding difficult to do that, please DM me on my LinkedIn. I'll able to help you out to your nearest user group. As I talk about, user groups allows you to do a lot of stuff: knowledge sharing, networking, getting new technology, reward certifications, etc. So again, I'll emphasize it. If you have not joined it, please do join today. With that, not taking much of time, let me introduce our speaker and the session. As you all know, the session is more about log analytics and content search via Amazon OpenSearch service. And for that, we have one of the renowned speaker here, Dipayan Sarkar. He is a senior analytics solution architect at AWS India, and we are really happy to get him. Let me bring him on stage. Hey, Dipayan, good morning. How are you doing today?
Yeah, good morning. I hope I'm audible. Hope everything going good. Everyone is happy. Let's start.
Absolutely. Before I pass on to you, Divyan, sorry, just a minute housekeeping stuff. Guys, if you have any questions, Deepian and here I there, I've requested Deepian personally to get 15 more minutes after the session to ask any question, because I know OpenSearch has picked up a lot in this new GenAI world. So if you have any questions about performance, optimizations, please put it in the chat. I will capture all of those questions and ask Deepian at the end of his presentation. So don't think we are not answering question. It is getting queued at our end. We will answer all of that at the end of the presentation. And just in case if you are watching this on demand mode, don't be sad. You can still ask the question in form of a comment, and I will personally route those all to Devian and get that answer to you guys. So this is your opportunity to learn from him, not taking much time and passing on to Deepian. Let me bring up his case.
Thank you. Thank you. Sure. Thank you, Sanjay. So I hope my screen is visible.
Yeah.
Uh, so let's get started. Okay. So what is search engine, right? If you look into the search world, right, there are a lot of things are happening into the search world. First is that whenever you go into any e-commerce site, right, or whenever you go into content, any content site, and just give something for a search, right, like free text you are writing, and then you see that maybe if you go in Amazon.com or IMDb, these are kind of, there are a lot of e-commerce site. If you go and then give the text, it is searching and giving you the relevant result, right, whatever you are searching. So these are kind of a search engine, and behind the search engine, there are a lot of things are happening, right? So if you look into the evolution of the search engine when it has been started, it started with a text search. So if you think like just for a beginner who are new to the search, like if you have a book, right, and you go to that particular book and search something from that book, you go into the index and then understand, look into that particular word or phrase and then go to the chapter to see what has been written. It's a search is like the same thing. We have a huge sets of data volume. We have a customer who generally stores terabytes and terabytes of data into the search cluster and then they do search. So first is that a text, right? Text search in the sense where you can just type anything in the free text and then you see the result. And second is that like how this search is happening, how we are storing these documents, right? So for that, you can store the document either through a streaming. For example, you have a logs, lots of logs you are there. You have a big application, those applications are generating logs, or maybe your IoT is generating lots of data or logs. And then you need to ingest the data into real time and see the things. And second thing is that if you have a database or application database which are generating data, or you have a content search, right? Let's say your product mapping in e-commerce, you are ingesting and seeing that. So before search, you have to ingest the data. Now, once you ingest the data, then you basically do the searching part of it. And there are multiple ways you can search. You can write a lot of queries like aggregation, fuzzy matching, spell check, synonym, the multiple things you can do when you are doing a search, right? Just like you think in database, when you write a SQL query to search the data or select the data, here is the same thing you're doing, but it runs in a millisecond or a sub-second response, right? It's very fast. And then we are talking a lot about the AI/ML technique. So when we are talking with the AI/ML and GenAI capability, OpenSearch has also this kind of capability. So when I'm talking the this kind of capability, which is basically a semantic search or the contextual search, means instead of looking to that particular term, whatever way you are searching, that search has some inner meaning, right? That it has some context. And understanding the context, then it will give you the search result. So that's a we call a vector search or neural search. So those are the many areas of AI/ML which has been now getting so many popularity among all of our customers. They are slowly moving, or they are moving to this kind of AI/ML search part of it, or vector search capabilities part of it. Now, what we offer into the OpenSearch AWS, we have OpenSearch service, and that OpenSearch service we use a provision cluster where you can deploy your domain. And we also have a capability of serverless, right? Where you do not need to manage any infrastructure. Generally, even in provision, you do not manage any infrastructure, but still you create the cluster, create the domain and all these things. But and it takes time. Like if you have a very big cluster, let's say 40, 50 node of this, then it will take time to provision the cluster because it install the software, it will install all the configuration and it will give you the cluster to you. And then there is a OpenSearch serverless. The difference between provision and serverless is that provision cluster, it's not scale automatically. So if you need to scale based on your data workload, you have to add or remove from manual. But in serverless, it will scale automatically based on your workload. Like if you have more workload, it will scale very quickly. We'll go in a little bit deeper when we'll discuss. And then we also have a service called OpenSearch ingestion service, which basically helps you to ingest the data from different sources, right? That could be your S3 or Kafka. So from those things, it can ingest the data into your OpenSearch. Now, once you have cluster, once you ingest the data, then you do the analysis, and for that we also have OpenSearch dashboard. So if anyone coming from the Elasticsearch world, you can compare these with the OpenSearch, right? So Elasticsearch and OpenSearch almost has the same functionality, but yeah, feature-wise, there are a difference. Like some features we have in Elasticsearch, some feature may not have in OpenSearch, something like that. But the major function, the main functionality, the core functionality is the same, right? In Elasticsearch, you will see Kibana dashboard. In OpenSearch, you can get the same thing in the OpenSearch dashboard. So that is it look like. Now, what is OpenSearch? Because if you look into the history of AWS, we already have Elasticsearch. We call a managed Elasticsearch. Now, that managed Elasticsearch is basically we support till the Elasticsearch version 7.10, right? So if you have Elasticsearch and you want to manage or you want to migrate into AWS platform, we support, but the version we support till is 7.10, right? Beyond that, we have the OpenSearch version. Now, why we move into the OpenSearch? Because in 2021, there are licensing things came, Elastic and all, then we decided that we will use the OpenSearch. And OpenSearch is a open source project. It's a Apache 2.0 license search and analytics project, right? Anyone can go into this open search project and contribute. It's a open source. So what we do, we basically take this open source, and we are one of the biggest contributor out. There are a lot of customer, they are contributing into the open search, a lot of developer also contributing. So even if you are interested and want to contribute in this open source project, you can go and then contribute, right? So what we do, we take this open source project from this open source, and then we package it and we manage it and we give it to our customer, right? So the difference you will see in the version, maybe in open source, you will see that they are in higher version and we are maybe 2 version less. That is the only difference. But most of the feature and other thing you will see into the open source project in OpenSearch that we are embedding into the managed OpenSearch project or managed OpenSearch service, right? So almost you will see that till this slide has been prepared, that 700 million OpenSearch project has been already downloaded. It has been picked as a top 4 search engine, right? There are a lot of partners, and 75 plus partners are already there. They are growing, and we are continuously adding new features, right? And for the roadmap, if you want to understand like how OpenSearch is evolving going forward, you need to depend on us. You can go into the open source project and see what are the roadmap, what are the feature going forward. And then there are multiple service providers. They are also using this open source in such project and package it and giving to multiple customers. So what is OpenSearch service? Amazon OpenSearch service. So it's a managed service, right? So in the managed service part of it, we do all the management activity. If you have a self-managed OpenSearch survey, so OpenSearch implementation, then you have to take care everything in terms of hardware, in terms of patching, in terms of upgrade, all these things you have to take care, the software installation, everything, right? But in the managed OpenSearch service, you are only focusing on creating a domain, ingesting a data, do a little bit tuning and such part of it. The rest of the management activity in terms of hardware, load balancing, security, all we take care from the behind. So that's the beauty of the managed service part of it. So it will reduce all your management activity. And these open search service basically help you to improve the relevancy of your search result. You can do a lot of analytics in top of the data which you are ingesting. That could be your content data, that could be your log data and all. And we also have a core capability of the vector search, which I already mentioned, where you can do a semantic search and you can use the rack-based search over there. We have a KNN, which is a nearest neighbor search, ANN, like approximate nearest neighbor search, sparse. We support a multi-model search. So all these things like the vector capability or AI/ML capability also inbuilt into the open search part of it, where you can bring your own model or you can use the inbuilt model to do the search part of it, right? The semantic search. It has a lot of integration with AWS native services, so it can quickly integrate part of it, and then it has a lot of levers to control the cost, right? Because cost is one of the pain point whenever you are creating a large volume of cluster and large as open search, you need to think about the best practices which you need to implement for controlling your cost. Right? Now, what are the things we offer in managed OpenSearch? What are the new things we have added? So we have added a auto tune capability in OpenSearch. Now, OpenSearch management is a little bit complex, right? You need to understand more about OpenSearch to do the performance tuning, understanding the uh, how the operation works, how the internal data distribution works, right? What kind of query you are writing, and for that, what CPU is using, what is the JVM, all these things to understand before you do the tuning of the OpenSearch, right? So to ease of use part or ease of our customer life or user life, what we have done, we have introduced auto tune capability. So it's a kind of AIML capability where it monitors your cluster and then it suggests, right, that these things you need to change into your cluster. Now, there are two things when it suggests. One is that it can automatically implement that changes where you do not require to shut down or restart your cluster, right? And there are few things. few changes. For that, you need to basically reboot or restart your system, right? So that we call a blue-green deploy. So whenever we do upgrade, whenever we do patching kind of thing, so where node restarts is required or server restarts or production cluster restarts required, we do a blue-green deploy. Blue-green means there will be a blue cluster and the green cluster. So we copy all these things, all the configuration from one cluster to another cluster. When the cluster is up, running, everything is fine, then we stop old cluster and give the new cluster. So in this process, you generally see there is no interruption of your workload. It happens seamlessly from the behind. So some changes you need to go for a blue-green deployment. So AutoTune will give you the advice that you can change those things. And then for that, you need to do a blue-green deployment part. And then call is yours, whether you want to do it. So it's basically ease of your management. Hardware, we do the provisioning, provision cluster hardware provisioning we do. And we have a multiple nodes, which I will discuss, which you can do select. And then based on that, we select the hardware. We do the configuration based on the type of node you are selecting, and we take care all the management activity of those nodes, right? We have a monitoring service, and that monitor your cluster from the behind. And then if you do a upgrade or update, like if you have a version upgrade from OpenSearch, you can do it online. So you don't need to any downtime required for this. We have a multiple tier of storage, which is very, very important when you are doing for a log analytics use case. I will talk about that storage sharing part of it. Now, what are the core features of the OpenSearch, right? So basically, if you look into the OpenSearch part of it, it comes into the database form, right? So, but if you look into the database world part of it, it has a more cooler feature rather than the normal database we see in our database world, right? Because that's built on top of the interaction model and interaction model for the search engines. So it's very simple, and it's a REST API based technology. So you have a data generator which is generating the data, and that data can be generated from your different server, from application, your network log, your IoT data, and all. So that generation, the data generation is coming to the OpenSearch, right? And that data, when it comes into the OpenSearch, we create an index. We call this the logical name. Index is a logical part of it, right? And under the index, there is a document, which means like whenever you ingest the data, there is a document, JSON document, which comes under the index, right? So index is a logical part. Under that, you have a document where you have a field and the data has been stored over there, right? So these are the simple JSON document which basically stored inside the index. Now, once you have data into the OpenSearch part of it, you can use a REST API call to ingest the data. And then once the data is stored into that OpenSearch part, and then you can start using another REST API call to query that particular data, where you can use a filter, where you can use a Boolean variable, right? Boolean search, where you can use the aggregation search, sorting, analysis, all these things you can do. So first is that data collect. Second is that ingest and organize the data inside the cluster. And then third is that you call that particular data and then see that, right, and do your analysis for it. So just for an example, if you see into any IMDb, right, where you are going and searching the something, then you will see, let's say, show me that this picture which has a director is this. Whatever you are writing, then will basically go and match the text which you have written into your search, and then it will give you the result where all these texts are matching. So if you look into that part in the right side part of it, you can see that is showing the Iron Man, then it is showing the year, rating, all. So these are basically the fields stored inside the OpenSearch index document, right? So whenever you are ingesting the data, you are basically ingesting the data related to the movie. And in that particular movie, you are saying that this is my title, this is my description, this is my rating, this is the writer, these are the stars who have acted in that particular movie, and all. And then it's stored into the OpenSearch index. And then whenever you go and search with some of the field, and then it will look for matching field and give you the data, right? So it's just a data structure stored inside the OpenSearch part of it. Now, this is a document, right? Like if I see what we store into the OpenSearch and how we store, so this is a store document. If you go into the OpenSearch and do the query and like show me in the query, if you write show me the film where this actor, the specific actor name has been acted. So it will give you this kind of thing in the document structure where you can see the ID, title of the film, where what are the actors has been acted. So you can see these are the JSON. You can insert the JSON. Also, you can insert the nested JSON. So whenever you have a data source and when you are ingesting the data into the OpenSearch, it will store this as a JSON document. So this is a document, and inside that document, you can see that fields, right? So actor is one of the field, director is one of the field, ratings are one of the. So just think about your database world, right? When you ingest a data into your database table, then you have a data type field and then their data type. OpenSearch has exactly the same. When you are creating an index, you are saying that inside the index you can define that these will be my field and these will be my data type. And it's the best practice. Whenever you create an index, you create a mapping of this field, right? That this will be my index name. Let's say index name is XYZ. And inside that, I will store these data type or these data. So you give the field, you give the data type, and then whenever you ingest the data into the index, it will ingest the data like this. If you don't define the mapping, still it can ingest the data, and that in that case, OpenSearch has capability which will understand your data structure, and then by default, it will decide what will be the data type for that field. But best practice is that you should create mapping part of it. Now, if you look into the OpenSearch part of it, just for a basic part and very high level, like how the documents are stored inside the OpenSearch and why it is so much faster, right? So if you go into the OpenSearch part of it, the core of full text search start with the analyzer, right? So analyzer means which process your raw text during the indexing and the querying of that data. So basically it breaks your text into the smaller unit, which we call the terms, and using a combination of your character filters, tokenizer, and token filter. For example, let's say if you are ingesting a document string, which is the quick brown fox jump, right? So what will happen? It will basically break each of these fields, like quick, brown, fox. So these are the terms, and these terms are stored in an inverted index. And basically, these terms have been taken care by the analyzer, which will basically take this term and store the data into the inverted index. An inverted index is a powerful data structure which maps each term to list of your documents. It appears, and it's like just like your book index, right? In a reverse pattern. So it will basically save these terms in store in this particular document. So when a user search for fast, like I mentioned, quick brown fox jumps into something, right? Fast or some letter it has given, then OpenSearch can instantly retrieve all documents containing that particular term, right? It will go into the inverted index and it will basically search that part. So there are analyzer which basically create these terms, and how those terms are organized into the into your inverted index is the key to building a efficient and accurate search experience. So analyzer, there are default analyzer, default tokenizer already built inside the OpenSearch part of it. Also, you can define your own custom analyzer. So, for example, you can define a language analyzer, or if you want to do analyzer in something else, you can define. But there are a lot of inbuilt analyzers are already inside the OpenSearch, which you can use when you ingesting a data, so that it can break the term and store it. Or and it will also work like when you are querying the data. So when you querying the data, it will also understand your query. It will use that analyzer and bring the go to that particular inverted index, see which document containing the terms, and it will give you the search result. So little bit inside of the OpenSearch. So in OpenSearch, there is a shard which is a basic unit of the data distribution and search. So when you create an index, what happens inside? So OpenSearch split it into a smaller parts which we call shard, and each shard actually a full loosened index under the hood. So it enables you for horizontal scaling. It will allowing you to be spread across your multiple nodes. So if you look into this diagram, then you can see that shards has been distributed into the multiple nodes. So why? Because it will boost your performance when you do a search. It will run the parallel processing of your query. And if you have a large data set across multiple data nodes, so using the parallel processing capability, it will return your search result much faster. Second thing is that it will also ensure your high availability through replica. So whenever you are creating an index, you creating a shards. One is the primary shard and another is the replica shards. So that primary shard and replica shard, they contains the same data, right? So which means if I have a node where I have a primary shard and suddenly that node, I lost the node because of certain hardware glitch, but still I have a replica shards, right? That replica shard will be that time primary shard and it will give me the search result or read write will be another, right? Read write, there will be no interaction. So that is the beauty of the primary and the replica shard. So in the best practice, you always keep a primary and the replica shard. The replica shard is not only giving you the high availability, but also it will take a very high contribution or it will do a lot of high contribution when you are doing the search for it, right? So it will ensure the data availability and it will also give you the search performance when you are doing a concurrent session. So what happens? Like whenever you are ingesting certain data for the document, so document will be routed to this shard using a hash algorithm, right? So hash of that particular document ID. So if you search a document, then you will see there is a document ID that OpenSearch generates, right? It has some algorithm. You use that and decide like which shard it will write the data. And the beauty of the OpenSearch is that it balances the load, it balances the shards, right? Like for example, here you can see I have a three data node where all my shard are distributed. It will always try to balance the shard equal, right? So and for your case, you have to also think the whenever you are creating a shard, that shard should balance across the node. For example, if you have a three node cluster and you are creating an index where you can mention that I have one primary shard and two replica shards. So what will happen? Your primary shard will be one node and two replica shard will be two different, right? That is the way it will balance automatically. Now, if you remove one node, then it will automatically remove the shard from that node and place the shard into other node. So shard rebalancing automatically take care by the OpenSearch, right? So internally, each shard is made up of a small files which we call a loosened segment, and these are basically immutable, right? When I'm saying immutable, means you are ingesting the data into the OpenSearch, but if you want to update the data, right? If I ingest a data, let's say I have ingest a customer data and I want to update the customer data, right? I want to update the customer location. So what will happen inside? It will do the insert and update. So it will mark that particular document as a deleted document and then ingest new document. And then there is a internal process we call merging. So when it will merge, it will create or remove that deleted document and create a larger segment for it. So I'm not going on that direction. It's a different concept we need to discuss. So whenever you, so basically you can now understand how data has been stored into the shards and or when you create an index, when you ingest a document, how it looks like inside the OpenSearch part of it. So if I see the relation between the shards, I spoke about segments, right? Loosened segments. So shard is basically like a searchable container and segments are the individual files that holds your actual document data. So your OpenSearch document is basically stored into your segment inside a loosened index, inside your shards, and within your OpenSearch cluster. So that is the way actually data are organized into the OpenSearch cluster. Now, if I look like how the indexing flow occurs, so here you can see that we have a document which I try to ingest into the OpenSearch cluster, and I have a three node cluster. You can see I have a three primary shard defined, primary one, primary two, primary three, and I have a replica for each charts, right? I have a two replica, so that you can see the replica has been distributed also intelligently, right? The primary one replica is in node two, and in node 3. So any point of time, if you lose any node, then your data will not go into it, right? So your data will be still there. Now, when you ingest the data, then the document will come into the OpenSearch. OpenSearch index analyzer will analyze the document, create the tab, send the data into OpenSearch node, right? Now, so before sending, like which node data will be there. So there is a routing algorithm or routing logic inside the OpenSearch that is inbuilt. It will decide like which node the data will be written. Now, if the question is, can you control it? Yes, you can also control it. If you want to decide that, no, I want to control this routing logic, you can also control it, modify the routing logic, like override the routing logic and decide which node you want to write that. But if you don't, then it will basically, if you depends on the OpenSearch, then OpenSearch uses its own algorithm. And then you'll say, okay, I'll write the data into primary shard 2, and then it will write the data into the primary shard 2. And then once the primary shard 2 data has been written, then basically it will replicate the data, right? Because it has a two replication. It has also mentioned the replication part of it. It will replicate the data into two shards, right? And then once the replication of the data has been completed, then it will return the result that, okay, I have successfully written the data into primary shard and the replica shard part. So this is the way generally indexing flow right? Now we have the search part of it. I ingest the data. Now I will run a query. So I have to call a REST API call, right? So I can write a get, put, post, this kind of REST API data. And then if I write like get, and then I give the endpoint of the OpenSearch and then give the index, right? And then write a search where I will write a query like this, right? That is queries. I want to search Iron Man. I'll give the fields, title, whatever I'll give, right? Like I'll write this query. And once I'll write the query, then how it will work, right? So it will basically go to the REST API call again, go to the search part of it. Again, it will analyze the data, whatever you have sent, right? Because it has to implement the analyzer. It will go to the node 3, and then it has own routing logic. It will implement the routing logic, search for part of it, and it will retrieve the result, and it will result back the data part of it. Now, each shards, whenever you see the result, right, you will see that there is a scoring, right? So each shards basically calculate a relevance for your document based on the factor like there are a lot of algorithms, right? Like TF-ID, term frequency, and the document frequency, right? So Lucent scoring algorithm generally use TF-IDA for VM25, which is by default to power this. So after gathering the result, OpenSearch basically merge them, resort them, and calculate the global relevance score so user can see the most relevant document fast, right? So that is the way it sorts and it will return you the result part. So how the OpenSearch service look like? If I see the OpenSearch service part of it, then the deployment architecture of OpenSearch managed services. We have data nodes and we have ultra warm nodes where we store the warm data and we have a master node, right? So that has been deployed into the customer domain. In front of that, there is an application load balancer which balance the load. That is implicit. You cannot see that part of it. And then there is a security, right? Security in the sense like how you access your cluster. So you can implement IAM logic, you can implement cognito or SML-based authentication to log into your dashboard for analyze your data which you have ingested. And for monitoring purpose, we generate a lot of metrics that you can monitor into Amazon CloudWatch metrics or Cloudflare. And then you have to ingest the data. And for ingesting the data, you can use a different AWS native service or any third-party service, right? As a native service, you can use Firehose or a database migration service, OpenSearch ingestion service, Kafka, manage Kafka. So those things you can use to ingest the data into OpenSearch and populate the data. And so now, if I look into the OpenSearch, how do you start? You can either start with provision cluster or you can start with a serverless cluster. So when you start with the provision cluster architecture, if you look into the previous slide, we have a master. So master node is basically storing all the metadata of your cluster, right? and it generally does not store any data. So that is a master node. And we always recommend that you should have a 3 or 5 master node because of the high availability. You should have a 3 master node, and one master node is always worth it. Other two are basically in high availability mode. So if one master node fails, then any of these master node will come as an active master node, right? So there is an election process, and in that election process, you select the master node, like which will be the next master node if one master node fails. So that's why you need 3 master node or 5 master node. That's a odd number of master. Then we also have a data node. In the data node, actually your data stored. So whatever document, index, search we are talking about, so all will store into the data node, right? Your data will be distributed into the data node. Then another node is also there, that is a coordinator node, which is basically do all the coordination activity. But if you don't implement the coordination node, then any of your data node will basically act as a coordinator node. Coordinator node means when you running your query, right, into OpenSearch Cluster. So there are phase of query, right? One is your fetch phase, another is a query phase, then it collect the data, right, and then basically decide like which data it will represent, and also these kind of coordination jobs does by the any of the data node if you don't define any coordination. Now, when you provision your cluster, then what you need to do, basically you will see we have a different node type, right? We have a Graviton-based instance, we have Intel-based instance. So once you go over there, you can decide like how many master node you need. So 3 is the master node, so where you can mention that I need a master node. And one more thing I'll add, you can also go without a master node. If you don't need a master node, then again any of your data node will work as a master node, right? So it will do both the functionality, master node functionality and data node functionality. But there is a high risk. Like if that data node lost, then you will lose your cluster because of this master node will lose. So best practice is in the production, you should have a separate master node and separate data node. Then you can go into the data node part of it. You select that data node, and then how many data nodes you want, what is the size of the data node, like what is the EBS volume you want to attach to store your data, that you can define. Now, if you see, we have a different type of data node, A, R, C, I, OR, OM. So why these type of data node is there? Because each data node has its own significance, right? For example, if you are doing a log analytics use case, we have recently introduced a WAR1 instance, WAR1 and WAR2 instance. Right? So those are very good for high indexing. Generally, log, your write is very high, read is low compared to write, right? So then you need to use a WAR1. Or if you are doing a use case where you need to read and write purpose, you need more memory, right? More memory intensive work, then you should think about a R type of instance. And you always think of Graviton instance because Graviton will give you the best possible. And then we also have instance like C, which is basically CPU intensive. So if your workload is more CPU intensive part of it, then you can think about a C type of instance, right? And then you see that we have also I type of instance, right? I generally for those instance where your IO throughput is very high, IO is very high, right? And in that kind of you do a lot of read write, you need a lot of IO. So instead of having the data into EBS, if you have an instance stored, then you will get a better performance. So in that kind of use case, you can select the I type of instance, right? So it depends like what is your use case and what you want to achieve based on in terms of performance, and then you pick the instance. And when you select the instance, we do a lot of configuration and we follow a lot of best practice so that you get the optimal performance when you are selecting instance. So that's why there is a specific requirement or there's a specific suggestion we provide that this instance type is good for this use case. Just I give an example. I spoke about like log analytics in case you can go for it. One or what2 instance, that's a newly introduced instance, right? Which is giving you the best performance. Right? Now, if you look into the OpenSearch serverless part of it, in OpenSearch serverless, it's a where you do not need to create these provision cluster nodes and all. You do not need to think like how many nodes I will need, how many shards I will need. All these things will be managed by AWS from the behind. And the other beauty is that you will get all the feature which I have discussed as of now into serverless, but will also give you the benefit of scaling. So it can scale in and scale out based on the node you are ingesting into the OpenSearch. Now the question will come like when will you use the serverless and when I'll use the on-demand provision. So provision cluster you use when you know that your workload is a 24 into 7, your cluster will be busy for either read or write, right? You have the same workload will come into the cluster. Then your OpenSearch provision cluster will be the best fit. But if you think that your workload is sporadic or on demand in nature, maybe 24 hours, your cluster will be maximum used for 12 hours or 10 hours, right? Rest of the time, you will not going to use the cluster. Or maybe you are expecting certain surge into your workload. So in that kind of situation, OpenSearch serverless is the best fit for it. So based on use case, you have to take a call which will be fit like provision or the serverless one. Now, how serverless work? If you look into the architecture of the serverless, so serverless is complete decoupled architecture. So there is indexing and there is a search, right? So indexing means you are writing into the cluster. Search means you are searching the data which you have stored inside the index of the cluster. So what we have done or what AWS has done, we have OCU, which we call OpenSearch Compute Unit. So indexing has used separate OCU. Search is also using separate OCU, and data is stored into the managed OpenSearch managed storage, right? So you can see it's a complete decoupling architecture. So, for example, if I need to add, or if I have an use case where I will write more data, but my search is low, then what I can do, I can give more OCUs to my index, right? I can do this. So in whenever you will create this OpenSearch serverless cluster, you will see there is a max OCU, mean OCU for your uh, indexing and the search use case. So max OCUs and mean OCUs means like maximum number of compute unit and minimum number of compute unit. Means whenever you have a load, it can scale, right? And how much it will scale, that you are basically defining. So that's a max OCU. And whenever it's scaling, where what will be the base OCU that you are defining. So when you are creating your cluster in serverless, you will see that for indexing, there is a two OCU. One is your main, and then another is the standby. And for search also, you will see two OCUs, right? So this is the way your cluster will be created, and you will pay as you go model, right? How many OCUs you are using, based on that, your charge will be there. So that is the charging model of the serverless. So it can scale very quickly whenever you are putting load. And for such use case, like your indexing is less, your write is less, but search is high. In that case, you give more OCUs in the search. So that is the beauty of serverless, where everything has been decoupled. You can control like how and where you need to put more compute to see the data. Then we have a ingestion service. So once you have the cluster, then you need to think like how I ingest my log data or how I ingest my application data part of it. So what you need to do, so you have a document, you have a log, you have a transactional system from their data is coming. So you need some collector, right? So that collector will collect the data, and then you implement the buffering technology or of that data. But why you will implement? Because sometimes we get a lot high data in very high velocity, right? So you need to buffer so that OpenSearch can consume the data, has time to consume that data. So we may need to buffer some data, right? So if the ingestion service which I am using has this kind of capability, that is good. Sometime also we need to do a kind of transformation. For example, I'm getting some log, I need to add some derived field, or I need to remove some field or do some kind of filtration. So that transformation also I need to do. So my ingestion should have capability that I can do basic transformation or some transformation of that data. And then I can ingest the data into the OpenSearch service, and then I can visualize that. So we built the OpenSearch ingestion service again using the open source project that is a data paper, right? So we use a data paper, And then we build the OpenSearch ingestion service. It is again serverless service where you can define like the OCU, like min OCUs and max OCUs to ingest the data into your OpenSearch part of it. You can protect your sensitive data, like if you want to redact your PII information, you can do that. You can implement the transformation logic for your like enrichment of the data, filtration of the data. So all these things you can also implement inside the OpenSearch ingestion service before you ingesting the data into the OpenSearch cluster part of it, right? So this is a kind of structure when you are ingesting a data. If you look into the left side part of it, you will see that these are the collector, right? Where data has been collected. So it could be S3, or maybe you have a Fluent Bit or Logstash, which is collecting your log file, right, from your application. Or maybe there is a Amazon MSK or Kinesis agent which are running, which is collecting the data from your application, from your log, and then it is giving to the OpenSearch ingestion service. Now, OpenSearch ingestion service is getting the data. If you want to implement any transformation logic inside the OpenSearch ingestion, you can implement that, and then you ingest the data into OpenSearch ingestion service, and then you can view the data into OpenSearch ingestion dashboard, right? So this is a kind of ingestion architecture which you can follow when you have a log analytics or any content or application data you want to inject inside the OpenSearch. And that new thing we also have been introduced in terms of zero ETL capability. So zero ETL capability is that uh, we know that this is an ingestion we can do either with OpenSearch ingestion service, or maybe we can use third party like Logstash, Blade, and maybe you can develop your own custom application to ingest the data part of it. But we also done the new things introducing a zero ETL capability. For example, if you have a DynamoDB, and from the DynamoDB, you ingest the log file or you ingest the DynamoDB data into your OpenSearch. What you need to do, you need to create the pipeline, right? You need to build the pipeline to ingest the data. Now, we have a capability called zero ETL capability where you do not need to write any code. So you create pipeline, right, in configuration, and then it will ingest the data automatically from DynamoDB to your OpenSearch, right? So that's the beauty of the zero ETL. You are not developing anything. It's a zero or no code kind of thing where you can move your data without building any pipeline. And we are giving the capability with DynamoDB, document DB. We have security lake. From there also you can ingest the data into the OpenSearch, and we have S3 and the cloud. Just for an example of use case, if I take, right, let's say I need to store a 10 years of log file for my compliance purpose. Now, if I store this 10 years of log file inside the OpenSearch, I have to pay very huge amount, right? Because I need a lot of nodes to store the data, so I have a lot of cost. So what I can do, I can remove my old data or historical data or old data into S3 and do the infrequent search. So once I move the data into S3, and then I create the zero ETL pipeline, and I can write the query and I can see the data seamlessly. So that's a kind of infrequent search I can do. For that, I do not require to build any kind of ETL pipeline and do this. I can also ingest the CloudWatch log without creating any pipeline, right? So these are the native zero ETL capabilities there. From this source, data can seamlessly move into the OpenSearch service. So that's another part of it. Now, if I look into the built-in integration of the OpenSearch, so ingestion, we have built-in capability with Kinesis data firehose, data migration service. Ingestion, I already spoke about, manage Kafka, document DB, and all these things. For monitoring, we have CloudWatch, we have CloudTrail part of it. For security, you can use SAML-based authentication, you can use IAM type of authentication, or any third-party authentication. You can build and secure your OpenSearch domain and the dashboard where you are querying the data. And top of that, OpenSearch also has a fine-grained access control, right? So fine-grained access control means whenever you are ingesting the data, right, you can decide that these log data or these index, I can only give access to these user group, right? Another user group cannot see the data of this particular index. So that is a fine-grained level access control also you can implement into the OpenSearch part. Now, operational and data management, which is very, very crucial into that OpenSearch part of it, especially for the log analytics use case. For example, if I take one use case, right, there are a lot of customers who are ingesting almost 15-20 terabyte of log data per day into the OpenSearch cluster. Now we spoke about replication. So if I ingest a 15 terabyte data and if I replicate one replication I create, that means 30 terabyte of data I am ingesting or into cluster, and I'm searching that data. Now, if I store the data for longer period of time, I need to add more data node. I need to add more compute for this search, right? And those kind of use case, especially for the log analytics kinds of use case, you will see log has their duration. Generally, we do a log analytics use case or log search or frequent search for 3 to 7 days, not more than that. Rest of the days, you can keep the log for your forensic or audit purpose, and then it will you have a use case for infrequent search purpose, right? So basically, what we will do, what we have done, we have created an open search domain, right, with a tiering kind of architecture. So where your hot data we are storing into the OpenSearch cluster. So when you are indexing, then the hot data is basically storing into the OpenSearch cluster, right? In hot. Then we have created a new node called ultra warm node, or we have facility of the ultra warm. What is ultra warm node? So whenever you log, you define a log life cycle that after 3 days, I'm not doing search frequently into this particular log. Let's move the log into the warm node, which is a less cost, right? Where we can move the data into the ultra warm. Now, ultra warm node has node which is giving you the compute, and then data will store into the again into the managed storage, right? Under the hood, it is S3. So you will pay the S3 cost to store the data. Second thing is that if you are moving the 15 terabyte of data or 30 terabyte of data, let's say 15 terabyte data you have actually, and then one replication 30 terabyte of log. So once you move the data into ultra warm, due to this managed storage, your data will not going to be replicated, right? Because is very easy. So 15 terabyte of data actually move into your managed storage. Top of that, you have a ultra warm node which will give you the compute, so that if you have a search beyond, say the use case is that I will store the log for my hot node 7 days, and rest of the rest 1 month log I'll store in ultra warm node. And now if I'm searching the log, my query where I am going beyond 7 days, it will seamlessly go into the ultra warm node, search your data, and give it to you. So you do not need to do any kind of configuration that how my search will work. Search will be seamless, right? So this is the part of the tiering architecture where you have ultra warm node where you can store your warm data. And then we also have a cold storage, right? So cold storage where we are just keeping the data into the storage, which is not read or write. Even in ultra warm node, you cannot write. It's a river. So cold storage data is not, you cannot search. So what you need to do for search, you have to attach this index into ultra warm node. There is an API call. So this API call will just attach the index into the ultra warm node, and then again you can search. So when you need a cold storage, let's say after 1 month, I want to store the data for 2 years or 3 years for my regulatory compliance purpose, and I want to store the data in low cost storage, and I'll only access the data if there is any audit or there is a forensic requirement is there. So this is the way I can saving a good amount of cost. I can save moving the data into different layer and managing my data. Now the question is how it will happen. Whether it will happen in automatically, or do I need to do anything for that? So in OpenSearch we have a policy called index storage management, or ISM policy, right? State management policy. So you have to define the policy. You have to define what will happen for your log file in certain duration, right? So you can say that I will keep my data hot tier for my fast search and indexing purpose for 7 days, right? And then you say after 7 days, you move my data to ultra warm layer. So you mention in that index state management policy, that's a JSON document where you say that your log file will move after 7 days into ultra warm layer, right? And then you can also define that after 14 days, you remove my log Either you can delete the log from your ultra warm storage, or you can say that you remove my log into my cold storage. So this is the way you can create the tiering of your domain or your provision cluster and manage it. But the beauty is that in serverless, you do not need to do any kind of ultra warm part of it, because serverless, we create the connection where we mention that whether it will be a time series or search-based data. So based on that, serverless managing. Now, this is another feature of the managed OpenSearch provision cluster, is that multi-AZ with standby. So what is multi-AZ with standby? Multi-AZ with standby is that generally you will see that OpenSearch, you will get a 99.9% availability, right? Because it has been distributed in 3 availability zones. Data will be distributed in 3 availability zones. So any point of time, you will not going to lose any data, right? But if you want to bring a 99.99 kind of availability into your cluster, then you can implement a multi-AZ with standby. So in that multi-AZ with standby, what will happen? That each availability zone, there will be the cluster will be created in 3AZ, and also in availability zone, there will be a replication of that data node. So in point of time, 2 availability zone will be active, and another availability zone will work as a as a your DR part of it, right? So that is the way multi-AZ standby will work. So any point of time, if you are losing any AZ, right, then immediately you will get the data from that particular availability zone, which is your backup, right? So this is the way multi-AZ standby will work. Then we also have a feature called cross cluster search for OpenSearch service. So cross cluster search is nothing but like, think about the use case where I have a different cluster in different region, right? So let's say I have deployment in Singapore, I have deployment in US, and I have deployment in Mumbai, right? And then what I need to do, I from Mumbai, if I want to search anything in the Singapore, so I can build the cross cluster search between these two domain, and I can do the search between these things. So this is a cross cluster search we can do between these two domains. This facility also given into the OpenSearch. So that is another part of it, right? So that is you can implement the fine grained access control to control like who will search what. This is the way you can also create a centralized dashboard. For example, I have Singapore, I have US, I have India, and from India, I want to create a centralized dashboard to monitor all my region. I can do a cross cluster search and build these things, right? So that is another part of the cross cluster search. So you can understand now that how you can implement the cost part of it, like using a Graviton instance, using your ultra warm node, right? So this is the way you can implement your cost, and you can control your cost part of it. Now, the two use case which mostly you will see into the OpenSearch, one is search, like your content search, and second is your log search, right? Now, in the content search, if you'll see that generally you will see industry like e-commerce platform, they use the content search. Then there are a lot of scientific research paper. You will see article, media content that has been loaded into some domain, and you'll see there are a lot of companies, they are giving this kind of facility where you can search a research paper, right? So these are another document portal where you can do a search use case. Then there is a recommendation engine, right? And also platform search capability. So search is one of the example of doing example of the use case which you can perform. For these things, if you see that e-commerce, right? When you do a e-commerce search, then you can do a text search part of it, where you can write a free text, you get the data from the product catalog. You can do a fuzzy search, like you can also implement the completion, right? Like the spell check. Whenever you search, you will see that it give you a lot of suggestions, right? So those are the things you can implement into the open search part of it, and you can do a search. So these kind of search generally we call a lexical search. So we support a lexical search part of it. And second thing, it's a feature you will see that is getting popularity. That is a semantic search, right? So for example, like it will be search in the based on the context, whatever you are writing in the query. It will search based on the context, and for that you need to embed the vector, and using that vector and like KNN and in capability, it will basically do the searching part of it. Now, how these kind of semantic search generally happen? If you look into the search use case, then whenever you ingest the data, right, that your image, that your document, that your audio, then what will happen? It will basically extract the data, it will create the chunk, right? And in that particular chunk, it will basically create the vector, right? So you defined like what engine you want to use or what model you want to use to generate the vector and embed the vector. So it will use that and it will basically generate the vector and store into the OpenSearch index, right? And then whenever you do a search, same thing, your search query, again, it will break down into vector and then search, go into this index, look for all these vector and return you the result, right? And it will understand the context which you are giving into the query. And based on that, it will go internal. It has own internal algorithm, right? ANN search and KNN search. So those are things are there. Based on that, it will look for the result and return to the result. So it will also support the vector search capability. Now, it also has a capability of the hybrid search. So what is hybrid search? So hybrid search means your combination of your traditional keyword search, which we call a lexical search, with your modern AI power search, which we generally call a semantic or neural search. So in lexical search is very good when you have exact word, right? It's basically fast and basically precise. But neural search goes further beyond, right? So it understands the meaning of your word, like it knows that car and automobile are kind of related. And even if the words doesn't mean exactly, it will, if your query has this type of thing, it will relate and give you the relevant result part, right? So in hybrid search, it will basically blend with your lexical search and AI search, and it will give you the result. Next, we also have a capability in OpenSearch that's the fine tuning of model, right? So imagine you are working with the content of a very specific field, like your legal documents or your scientific paper. Now, out of the box, model might not perform well because they weren't trained of your domain data, right, or kind of data which you need. So with this OpenSearch, you can fine tune a neural model using your own text corpus, even if you don't have user click or behavioral data, right? So these basically tailors the model to understand your domain better, and it will improve your search result dramatically. We also have sparse vector or a retrieval vector search, right? Like this sparse vector is basically bridge between your the world of AI and the traditional keyword-based search. Then we also have a multimodal search. So this means that you are not limited to just text. You can also search across image and text seamlessly. For example, if you upload an image and search for a similar item, even if that image was never labeled or pre-processed, still OpenSearch can compare that visual content with both image and text description for your data. So if I look into the OpenSearch capability, it is not just a search engine, right? It's become a smart retrieval platform with giving you the hybrid search capability, domain specific fine tuning, multi-model capability, and it's giving you a tool to deliver better, faster, and more intelligent experience part of it, right? Now, if you look into that, when I'm talking about the model connectivity. So if we go a little bit deeper, like how it integrate models through the in AWS, so you can use AWS Management Console, right? So this part is basically useful for who prefer a low code, no code kind of setup and want to experiment model very quickly using a SageMaker text embedding model, right? So you can directly integrate retained or custom SageMaker model that generate text embedding, and it will help you embed your OpenSearch platform like semantic search by capturing the meaning of query rather than just keyword search. And it can also integrate with Amazon Bedrock, right? For example, if you have a Titan text embedding model you want to integrate, you can integrate with Amazon Bedrock also. Now, in terms of real-time analytics, generally you will see the real-time analytics is application monitoring, security monitoring, log analytics, observability. Those are basically a real-time monitoring of your application, of your basically of your application, right? Where you are generating a lot of data, where you need to monitor and you create your observability part of it. So for that, we already discussed how you can ingest the data, right? You have a producer, you have a different collector, then there are different aggregator, and using that, you can ingest the data into the OpenSearch cluster. Now, once you ingest the data, then you can create a dashboard, right? And it has a very good capability which you can use to build this kind of dashboard for analysis your log data, right? Or build your observability data. So observability in OpenSearch is also very useful use case, and we are seeing a lot of customer nowadays using the observability part of it. So it is OpenSearch is a log analytics tool, and this means that you can see, search, filter, and analyze your log from your system to identify issue or pattern. It has built-in anomaly detection and alert capability. So OpenSearch comes with a built-in anomaly detection. So it automatically looks for a pattern or behavior that you're unusual in your data, and it will help you to spot problems very early. So when an anomaly is detected, the alerts are triggered to notify your teams, so you can take action before a small issue becomes a bigger problem. So it will give you the proactive monitoring kind of capability, right? Third thing is that in observability phase, like you will see open telemetry data. So open telemetry is basically a open source framework that helps collect your data about the performance and behavior of your application and the service, right? So these data comes in the form of logs or metrics or maybe in trace. So if I break down, right, like log, metrics, and text, so generally logs are the records for events happening in your system. So they tell you things like what is the error, what is the system status, or user activity. If you go into the metrics, then metrics will give you the high level view of the system performance, like how much memory you have used, what is the CPU you have used, right? This kind of metrics you can get. Now, there are third thing, which is traces, which is very important. So traces basically show you the end-to-end journey of your request as it flows through your different services. For example, like if you have a microservice kind of architecture, right, where you have clicks a web app, and in that way where you are taking some product, you are inserting that product into the your cart, and then you validate it, and then you submit the card, you make a payment, and then product has been ordered, right? If I build this kind of journey or this kind of microservice architecture you have, then how do you understand like which service is performing slow, or where is the problem, right? So in that kind of thing scenario, you need to generate the telemetry data or traces, which will give you the journey so that you can understand which service is not performing well, right? So these, for that you need to generate the telemetry data or traces for these things. Fourth is that like you have a log pattern, right? You have log pattern which will give you the log, which will give you helpful feature like what are the log pattern, what is the common log event. You can also tell logs in real time to monitor like your ongoing activity. OpenSearch also support processing language, query language, right? So it has a unique query language which we call a PPL, where you can write a custom query to filter, analyze your log data, and it's a powerful and flexible for explore your data in detail and get inside our data, right? So these are the things you can get like when you are building the observability dashboard into the OpenSearch. And these observability dashboard here you can see, right? It will show you if I see that I have a MySQL database, I have customer data, I have your different search data, how my journey has been there. Now, if I click each area, I can understand which service is giving a problem, and where is it is slow, and where is the error. If I want to use this trace and correlate the trace with my log file, that is also possible into the OpenSearch observability dashboard part of it. Now, you can also do a security analytics into the OpenSearch, and it comes with inbuilt feature which support a common security log source, and that includes log from your different system like your Windows or your CloudTrail, DNS, and other things. And you don't need to do any kind of extra setup to start analyzing this log. It will help you to reduce the time it takes to respond the potential threats. Now, if you want to do the detection of the threats, right, inside your log, you can also implement, because OpenSearch includes more than 2,200 open source Sigma rules, right? And these are the previous security rules used for detect your suspicious activity. So you can create your own custom rule based on your specific need, and it will make you easier and faster to find out potential threats in your data. That means you can do a proactive way of monitoring that if there is any threat is coming. Now, once you detect, then it has also alert mechanism. So, right, it can give alert to your different stakeholder when you detect the threat part of it. Right now, how it works, like first you need to identify and ingest the log. So the first step is that so that it could perform system like your CloudTrail or your Windows log or system log or your custom application log. So once it identifies, then you need to ingest this log into OpenSearch, which means you importing the data so that OpenSearch can start analyzing it. So you can use a built-in integration to make this process quick and easy. Next, you need to define a detector, right? So you create a detector into OpenSearch. Detector is basically a tool which will scan the ingested log for your suspicious activity. So you can think of it's a guard, right? That watch over your logs and looking for anything unusual or potentially harmful happening to your system. Then you define a rule, right? So once the detector you set up, then you need to configure a rule, which rule will define that what OpenSearch should look like from that particular log. For example, you can use prebuilt Sigma rules, or you create your own custom rule based on your security needs, and it will help OpenSearch to recognize the specific threat. And once you have done this, then you need to do the alert configuration, right? Because you have detect, you have defined a rule, and then you need to configure your alert, right? So you can set up alert to be sent to a different destination, like through your email or maybe through your Slack, right? So using that, it will send the alert, and then you can do the response or auto-generated findings, right? So where you can once the alert is triggered, then it will automatically generate a finding and detailed report the data, like what threats you have done. So your team can come review the finding and take the necessary action part of it. So you can implement this into the OpenSearch part. So this is a kind of dashboard example where you can see a security analytics experience, right? How you can build this kind of enriched dashboard. And then this is a trace analytics, right? I mentioned that if you have different developers and IT ops team use their feature to troubleshoot the performance and the availability issue in their distributed application. So they will get the end-to-end insight in using this kind of trace analytics dashboard, right? So you can add a trace data to existing log analytics capabilities, and then you can use the same service to both isolate the source of performance problem and diagnose the root cause you are facing from, right? So you can see that in terms of observability, these are the feature we discussed into the OpenSearch, where you can combine the log, trace, CloudWatch log. It can scale. It supports a 2,200 Sigma security logs, right? It can generate a real-time alert for a proactive monitoring part of it. And these are the resources if you want to do hands-on, if you want to know more. So these are the resources you can go and check to learn more about OpenSearch. So that's all from my side. And if there is any question, anything else, I'm happy to take that. Over to you, Sanjay.
Thanks, Deepyan. I think that was really wonderful session. I was excited to understand the different patterns. You have not just covered up the what's OpenSearch, but the different patterns of what we see in the industry and how people are working around it. So really appreciate your effort to help us on this weekend to understand about this. Uh, I don't see any question at this stage, but audience, if you have any questions, please put it in the chat. And again, if you're watching the session on demand basis, please don't hesitate. Put your question in the comment section, I'll have Deepyan answer all of those offline. So we'll take a minute. If you have any questions, please put it in the chat. And again, we have the session last week, also 2 weeks back. Next 2 weeks back, we'll have another session. The speaker is very interesting. She's renowned for her data engineering skills. So stay tuned for the announcement. And for that, if you want to understand it, you need to subscribe to our social media platform, either of them. So the links are already in the comment section. Please subscribe to that so you get an idea about who's the next speaker from our community. So, Deepyan, I mean, I don't see any question from the audience, but I do have one question. I know you talk about
Right.
interesting pattern which I foresee in the market a lot happening is the chatbots, right? FAQ with GenAI, which has been very promising use case across industries, like how FAQs you talk about, employee forums you talk about, post sales, customer feedback, right? Uh, can you help us? Can you help our audience to understand what's the significant? How exactly OpenSearch is playing a significant role in those kinds of use cases scenarios?
Yeah, so if you see especially if you see like in our customer part of it, they are mostly moving into the chatbot and the RAG kind of use cases a lot, right? Because why they are moving in that part of it? Because first thing is that you are getting ready-made LLM model, and the second thing is that if you have a domain-specific data, which I was talking, right? Let's say I have a customer who are basically doing a scientific research, right? They have a lot of scientific document, article, and all those things, and you are searching part of it, right? Now they are planning to think, right, how they can bring the GenAI capability on that part of it, right? Like it could be chatbot, it could be RAG-based thing where you will just give a certain medical terms, not all the medical. You will go into that particular medical terms, understand the context of your search related to that medical term, give you the result, right? And then once you have the result, then you can do a chat, right, for better understanding, go more depth part of it. So how OpenSearch is helping that, right? OpenSearch is now working as a vector data store, right? So whenever you are generating a data, so it is basically generated a vector inside for specifically for AI/ML use case. It generates a lot of vector. It supports, and there are a lot of things also, right? Like Sanchit, if you look into this, if you have a huge sets of document, then how you will create the vector, what will be your dimension, because it needs a lot of space into your memory, right? Now what kind of quantization technique you will implement, how you will implement the performance, all you need to think about it. So where it's a separate chapter, right? You need to understand like how you generate the vector, how the quantization will happen, how normalization will work, all these things you need to understand in very details before going to this kind of chatbot, this kind of RAG analytics use case. It's very easy to hear, but you need to have a proper plan, like to select the right size of node, select the right engine for your indexes. All these things are very crucial and important. And it is OpenSearch is really scaling on that front because you know that log analytics, observability, all our customers are doing now. Now they are moving into different paradigms when the Gen AI or AIML is getting more popular, like agentic AI also coming into the OpenSearch nowadays, right? We have included a lot of model inside the OpenSearch now due to that.
Got it. That sounds really interesting. I think I will reach out to you offline to see if you have any
Sure,
availability in the near future, so we can have more understanding about this, right, for our audience. Uh,
absolutely, absolutely.
yeah, I only see thank you messages in the chat where people are like your session. I don't see any questions anymore. So with that, thank you so much, DPN, for spending your time with us over the weekend. I know it's busy your schedule, like. Oh, with that, I see a question from Anil. Let me flash it up on the screen. When it comes to the logs, are there standard templates provided by OpenSearch which can be leveraged by the developers and administrators to standardize their log capture across the solution in an enterprise?
Yeah, so to answer this question, there are two answers, right? First is that if you think that if you are using OpenSearch ingestion service, then we have Blueprint, right? You can use that particular Blueprint to create your log file. log, right? Generally, we don't have any log structure. But if you have you can ingest any type of log. You need to define the structure of your log and then ingest. That is number one. Number two is that, let's say if you are taking the log file from the frame bit, right, or log stash, so then you are using our ingestion service, you will get a YAML or JSON file as a blueprint. You can use configure. But how the structure of your log looks like, it depends on kind of log you are generating from your application, right? If it is a custom application, then you know what will be your log structure, what you need to ingest and all. So you can ingest, but ultimately it will ingest as a JSON document, right? So inside the log. So there is no defined structure of the log. But yes, if you think about a security analytics part of it, and you want to last few slides I was discussing, right, like detection, threat monitoring, threat detection, and all these things, then we have a standardized log format, right? Once you define this kind of security threat, we have a standardized log format. Like we support AWS CloudWatch log, CloudTrail log. We know the structure, right? So almost there are multiple log structure we support, and you create the threat and detection model on in terms of security. But if I look into the log analytics use case, you can bring any log where your system log, your IoT log, whatever log structure you have. And before ingesting the thing, the best practice is that you should create a proper mapping document so that OpenSearch will take your or you control it rather, because sometimes we have seen that if OpenSearch going to understand your document and create a data type, there could be a mismatch, right? Some fields like date maybe created as a string and all. So you will see a wrong search result. So if you ingest the document, you can define your structure. Ingest. There is no standard thing for the developer part of it.
Anil, I hope that answers your question. Moving towards the next question, we have interesting one more. What is the cost involved in OpenSearch service enabling, and is it possible to provide some use case related to observability?
So cost is that part of it. OpenSearch will cost in provision cluster. The cost is basically the data node, right? Type of data node you are selecting. And if you go into the our website, there is a public pricing for each data node per hour we charge. Let's say if you are using R6G to X large, it has a per hour charge. So if it is running for 24 hours into 24 into 7, then what is the hourly charge into say 24 or maybe 730 generally we calculate. So that is your charge for your compute. Then we have a charge for the storage. So if you are storing say 100 terabyte of data or say 50 terabyte of data, then you are using EBS volume, that EBS volume charge you have to pay, right? We don't charge any inter AZ. So if you have three data node which has been distributed into three AZs, we don't charge any data ingress egress between this AZ, right? So you only pay the cost for compute and cost for the storage. But if you look into the serverless part of it, serverless is charged with the OCU, OpenSearch compute unit. So how much OCO you have consumed for how many hours you have to pay the charge for. So that is the charge part of the OpenSearch, right? And observability use case is many observability. Most of the cases you see there are observability in the sense, for example, I gave you the use case, right? Like I want to observe my application data plan, right? Like how my microservices are talking to each other, how they are working, which microservices are slow. If one of the services are giving the error, I can correlate that trace to my log and understand that this microservice is giving me the error, and this is the actual error part of it, right? So observability is basically give you the monitoring capability on top of your log, metrics, and traces, right? So that is basically your observability part of it. Generally, you see there are multiple software, right, or multiple vendors are there. Datadog, they do observability. It's not fuel based, and OpenSearch is also one.
Interesting. Uh, there is one more follow-up question, Dipi, I think from Anil. I think he agreed your previous response, and he also have follow up. Does OpenSearch provide any transformation service to convert to a standard format?
OpenSearch transformation service in the sense like if you are using OpenSearch ingestion service, there is a transformation capability. So it has source, it has processor, it has sync, right? So inside the processor, you can do a transformation if you want to do transform.
Guys, we'll wait for a few more minutes. If you have any questions, please put in the chat. Interestingly, I see like a lot of question has come up now in last few minutes.
Yeah, I know because OpenSearch is little bit complex. Whenever for a beginner, it has to be little difficult to understand like what is OpenSearch, how it works, what is shard, all these things. So that's why I just try to give some hints about like what is shard, how it distribute and all. But each has its own topic and depth. So you need to understand more in detail to manage
Correct.
and OpenSearch.
Correct. Absolutely. I 100% agree with you, right? So I don't see, I think we are good, DPN. Thank you so much, DPN, again, once again, for spending your weekend
No problem.
with us.
No
Absolutely, let's
problem.
stay in
No
touch.
problem.
I would
Absolutely fine.
love
We're
to,
happy to connect with all these user
correct.
groups. Thank you for giving
Absolutely.
me
We
the
will love to
opportunity.
host you back in near future about running one more advanced complex session around OpenSearch. As you mentioned, it's a pretty depth. I don't think one session will justify for it. So we'll stay in touch and we'll
Absolutely.
come up with the part two for this one. And with that, thank you so much, audience, for joining and tuning in for our session today. Again, as a pardon, if you're watching this session on demand mode, if you have any questions, please don't hesitate. Put it in the comment section. We'll have the PN for answer all of this offline when you get a chance. And again, please subscribe to any of your social media platform. We'll have our next session on June 20th, 28th, and we'll have the speaker from our community. She's very renowned, a renowned face for our courses on LinkedIn. So stay tuned for the announcement of the speaker, and I'll see you on June 28th. With that, thank you so much. Stay safe. See you in the next session. Thanks,
Thank
DPN.
you, guys. Thanks. Yep. Bye.